Welcome to Microsoft Build 2017. I'm Ross Sponholtz, and this is my friend Stephen Follis.
Hello.
We're here to today to walk through a scenario of taking an application that's running on Stephen's local developer desktop and moving it to the cloud. So first, we're going to lift and shift the application into a single Azure virtual machine environment. Then we'll describe how we will enhance that application to take advantage of Azure Managed Services. Finally, we'll deploy the application into multiple regions, leveraging Azure's global infrastructure. So first, Stephen, why don't we take a look at the application on your laptop?
Absolutely. So what I have running here as I switch over to my browser is the City Power and Light application. This is a simple application that's really focused on municipalities. It's a portal to be able to register and monitor different kinds of outages, incidents that are happening across that community. So here we have a landing page. We can go to a dashboard view where we can see a variety of incidents. We can click in and get more information around potholes, where they happened, some more information here around an ID. Then we can also go and report an outage. So if we had an issue, say with a down power line, we can put some information in there. We can give it, an address. We can select a photo here. So I've got a little photo of a city that's having a power outage right now. And then we can submit that incident. So all this takes place right here in the portal.
This is a very simple application. Just
basic CRUD operations. This is, from a development standpoint, this is a 3-tier application, very traditional. We have a web tier, we have an API tier, and we have a backend database. The web tier is an Express.js application written in Node. The API is a loopback tier for a nice Swagger-ified RESTful service layer. And the backend is actually MongoDB, using a very popular document database to store this information.
But we also developed the application in Java as well, right?
We do. And on the GitHub, you can find a Java version as well.
Super. But basically, it's a sample application to show how all those 3 tiers can work together.
It is. And again, all running right here on my machine with a local Mongo instance, all the code running here. Developed out in Visual Studio Code. We've got all of our code right there as well.
Nice. Well, so that's not a great place to deploy your production code on your laptop. So we want to create somewhere in Azure to be able to run it, right? So we're going to use an Azure Virtual Machine for this, but we could have used Azure Web Apps, Azure Service Fabric, Azure Container Service. So why don't you tell me a little bit about why we chose Azure Virtual Machines for this?
Sure. So we have a variety of deployment targets on top of Azure, both from an IaaS standpoint and a PaaS standpoint, multiple options. We're using a virtual machine today out of familiarity and simplicity. Oftentimes with lift and shift scenarios, we want to move into a very familiar environment without a lot of changes to our application. So we're going to start today with a single virtual machine running an IaaS, and then from there we'll work on adding in PaaS services on top to enhance the application.
Okay. So why don't we start off with creating a virtual machine in Azure so that we can have a place to host this application?
Absolutely. So we have a variety of ways that we can do this. Today, in the spirit of keeping up with our open source application, I have the Azure command line interface. And so what I'm going to do here, I'll create a group called CPL for City Power and Light. I'll give it a region. And this is creating a resource group, which is a way that we can logically contain multiple resources together.
So then you can manage that group, you could delete that all as one unit, and you can contain things like storage, network, and virtual machines all as a unit, right?
Exactly. It'll give us nice management over the entire life cycle of those resources in one easy to manage container.
So you're using the Azure, as we call it, the Azure CLI, which is the cross-platform command line interface that'll work on Windows, Mac, Linux, what have you. Yep. So why don't you show us a few of the features in the Azure CLI? One of the things that I have a problem with when it comes to the CLI is or with any kind of command line interfaces, I have to remember the options available, right?
Absolutely. So let me open up a new tab here. And if I just type in AZ, we can see all the different commands. Oh, excuse me, that opened up a PowerShell prompt. So I'm using here a program called Hyper. It's just a fancy UI layer on top of PowerShell or command prompt. But when I type bash, this is actually allowing us to boot into the Linux subsystem for Windows, which is a full instance of Ubuntu running right in our environment and allows us to interact with a bash prompt in a very native way.
So you can use things like grep and find, all
awk
in
and all
Windows.
those fun things without it being virtualized or similar. It's the real
So the
thing.
transition between your Bash environment here and your Linux virtual machine in Azure is really easy.
Exactly. I could be doing this exact same demonstration on my Mac at home if I wanted to. So when I type in AZ, we can see all the different commands in the Azure CLI. All these different components on the left correspond to services or features or resources inside of Azure. Earlier we did an Azure VM create command. And if I give a -H after this, it'll tell us all of the different arguments and components that we can configure when we're doing that create statement. So we
And
can,
there are usage examples too, so
Exactly.
you don't have to interpret a man page, right?
Exactly. So we can see here, so I specified an image earlier. We used the Ubuntu LTS. We could have been very specific and had that's kind of a shortcut for the latest Ubuntu LTS image. We could have had our own. We could have had maybe a golden image for our organization. We have a lot of control over what type of image we use for that installation. I want to call it that we gave a generate SSH keys argument. And what that was allowing us to do, you'll notice I didn't put in a username and a password. But by saying the generate SSH keys, actually used SSH keys to do the authentication for us.
So that would be a secure public key encryption for accessing your virtual machine, rather than using username password.
Exactly. And as a developer that's moving into in and out of multiple virtual machines, I love using my private key to authenticate rather than having to remember different sets of passwords.
And it's much more secure, right?
It is.
So we're using the CLI, which is awesome here. I love the CLI, but we could have used PowerShell if we wanted to, right? And we could have used the Azure portal to create the same thing.
Absolutely. You could have even gone against the raw REST endpoints for the Azure Resource Manager and connect that way as well. We have many options for however you'd like to connect to Azure to provision resources.
So let's see if how the application or the virtual machine creation is
Good.
going.
So we've created the virtual machine.
is
I'll
that
grab
done?
this. Created a public IP address for us. What I can also do here.
We want, for our application, normally in Azure, when you create a new virtual machine, you're just going to be able to SSH and that's it. There aren't any other ports open to the machine because we take a more closed approach to that.
We do.
So we're going to have to open up the HTTP port to be able to access a web server.
We are. So by default, we stood up a virtual machine, but Azure went ahead and also gave us a disk, a NIC, a virtual network. And with that virtual network came a network security group, which, as you said, comes by default locked down. The only port that's open is 22, which is the port for SSH. And so what I ran here was this AZVM open port. And from the command line, this is allowing us to open a port on that network security group to allow that HTTP traffic through, which is kind of important when you have a web application.
Yeah, no kidding. Fantastic. So
yeah.
that just takes a couple of minutes, and then we'll have our application.
And there we go. So now we have that port that's open there.
Okay.
Okay, so at this point, we've provisioned that virtual machine. We've opened up a port for the web app. We need some code to actually
We need to put the code
upload.
on the machine, right?
Right, so what I'm going to do is I'm going to run what's called an SCP command.
And that's just secure copy that's available on all the platforms, along with SSH, basically using the same technology.
Yeah, so we could FTP this code into there. We may have a CI/CD pipeline that'll push our code. There's a variety of ways to get our code from developer machine into our VM.
We're
this
just
is
taking
about the
a simple
simplest
approach, yeah.
Exactly. So I've copied those files up for my local machine. If I SSH into that box, we can see I'm still on a command prompt, but my machine's changed that CPL VM. And if I list the files there, we now see our code is situated right here. I'm going to run, I've got to set up a shell script here, and so I'll kick this off while we're chatting. I mentioned earlier that we're using Mongo, we're using Node.js, and we're also using a program called PM2 that helps us move our app into a process that's running on the machine and manage that lifecycle.
So your script is just installing, doing the apt-get or what have you.
It's configuring the machine for all the dependencies that I need for my application. And so instead of sitting here hammering out multiple lines, I just put into a shell script, also available on GitHub. But this is, again, when we provision a virtual machine, we chose a blank Ubuntu image. There's nothing on there. We could have selected an image that may have some of these baked in. If we use the same components every single time, we may want to generate our own image for that. We have a lot of options on how we do configuration, even Chef, Puppet, ARM templates, custom script extensions, all options for configuring the virtual machine after we provision the virtual machine.
Now, it looks like the provisioning and installation is almost done. The PM2 program was especially interesting to me because it's an easy way to start up services, right?
Right. Yeah, it's just in the node world, it's one way that we can manage that application as a service in the operating system there.
So then when we log off of the virtual machine or bounce the virtual machine, it's going to bring the service up automatically.
It is.
Right?
It's just a nice, convenient way to manage those processes there. So what we can see here is I've also scripted out, this is running an npm install, akin to maybe restoring my NuGet packages. All the application dependencies that I needed for that application are being restored so that we can then, hopefully in just a moment here, run that application. So.
All right, so do you want to bring up your browser and get that ready with your IP address?
I will, good. So we've got that, so as we can see here, looks like we've got the API and the web app are both up and running. So if I switch over to the browser, this was localhost here. If I open up a new tab and use that IP address we had earlier, you can see now we've got City Power and Light running in the browser, but this time, instead of my local environment, we're running up in an Azure virtual machine.
So that's fantastic. It's all going to be running no matter what we do on our machine there, of course. So since that's just a single machine environment with the application, the database, everything running within that same virtual machine. So what are the next steps we want to take to make that more cloud ready?
Great question. So right now, again, all three tiers, web API, database, all right in a virtual machine. It would be very difficult to scale this application. If I needed to, if I got a lot of users and my traffic increased significantly, it would be difficult to make this application work. We could scale up to a larger VM, but at some point we're going to run out of size to use there. So we often talk about wanting to horizontally scale and have multiple instances.
And we need the application to be stateless to be able to do that, right?
Exactly.
That we can't be holding our information in the application. It's got to be external to it.
Exactly. So just starting with like the database, for example, makes this VM very stateful. All our data is in one spot. So we can start looking at platform as a service offerings on top of Azure that can make our lives a bit easier and can help us externalize that state in a very predictable way.
So starting with, I think, the storage, right? You have image storage in the application. We were putting that on the local hard drive. Where are we going to put that in Azure?
Right, so those images that we uploaded, right now going on the local file system, not a great spot to be putting those. So we can externalize those images with an Azure storage account. So we have, under the Azure storage family is blob storage. Blobs are perfect for images, videos, large binaries that we need to externalize out of our application. The other big benefit is it's very durable. We replicate that many times, both locally, or you have the option to go geo-replication there.
And hugely scalable, too.
Very scalable and very affordable as well, which is nice.
Well, what about the database? That's really, I think, my biggest concern, right?
Yep, absolutely. So after we've externalized those images, the database tier is essential. So what we chose to use as we were scaling up this application is DocumentDB, which is a managed service on top of Azure. It is a NoSQL document database, very similar to Mongo. And one of the nice benefits there is that DocumentDB on Azure actually talks the same protocol as MongoDB does.
So you didn't have to make any code changes to move from your local Mongo database to using DocumentDB.
Exactly. So my application communicates over a standard Mongo component. I simply changed the connection string to point to Azure's DocumentDB, and the application was able to continue and chat as normal. We need to migrate the data at the initial point, but from that point forward, we can use Azure DocumentDB as a managed service to where we're not having to mess with VMs and clusters and replica sets. It's all handled for us in a highly scalable manner, and one that can be geo-replicated as well for that data tier.
So what about performance improvements? I'm thinking about caching.
Yeah, caching is essential. The less demand we can throw on that API tier, or even onto that backend DocumentDB tier, is going to be much better performance and be much more responsive for our users, leading to a much better user experience. So what we chose to do here is we stood up a caching tier in between our web tier and our API tier. We put some caching in front of that.
And that's the Redis cache,
Exactly.
the Azure Redis cache.
Yeah, so Redis being one of the most common products for caching that's out there. we actually, on top of Azure, offer Redis as a managed service. So again, I don't have to go fiddle with VMs. I can focus on my application code.
You don't have to worry about the uptime of your own
Exactly.
cache. You just use it as a service.
Exactly. So we use the Azure Redis cache, allowed us to use Redis in a managed way, which was much easier for us.
And that would also be a really convenient place to put any session state if the application had sessions. We don't in this one.
Exactly. So by moving that session state out along with these other stateful components, gives us a much more stateless environment, and especially for an application that may not be as stateless as it was if it needs that session state, we can at least externalize that to something like Azure Redis Cache.
Great. Now that it's in that expanded single machine environment, then I want to think about scalability, right?
Sure.
On that single virtual machine, we're pretty limited. We can go up to a certain number of requests per second. And I'm thinking horizontal scalability. Let's talk about that a little bit.
Good question. So we have some options here as well. Once we reach that statelessness for our virtual machine, we could manually provision and configure additional machines. So we can go with an ARM Azure Resource Manager template, Chef Puppet, whatever we have there. We can stand up multiple instances of those VMs, all inside of the same availability set, which gives us some benefits, and it's kind of a best practice for running multiple VM workloads.
So that they're consistent.
They're consistent. They're not all on the same rack in case we need to update or there's a problem there. So the simplest way is to manually manage those. As you can tell, when I say manually, there's still a lot of work to manage those VMs, to patch them, to make sure they're up, to do more configuration there.
Look at the users and make sure that ports are closed or open as they need to be, and all those processes.
Right. So we actually, on top of Azure, a relatively new feature of the platform is the ability to take away that manual process and use instead what we call virtual machine scale sets, VM scale sets. And in this world, we create kind of a master. Here's what the VM should look like, and then we allow the platform to duplicate that for us. So we'll say, I want this VM and I want 5 of them. And Azure will say, okay, and it will go stamp out 5 or
and they'll
10,
be identical.
or 1,000, however many we need. Yes, and they're identical, and we don't have to manage each of those independently. We have kind of an abstraction layer for multiple VMs when we're scaling horizontally.
And also, if we have a variable load on our applications, say seasonal or different times of day that people use it, we can use the Azure auto-scaling so that we can grow and shrink the environment to make sure that the users always have a good experience while keeping the cost down, right?
Absolutely. Auto-scaling is one of the best features of VM scale sets, and allow us to define some rules, maybe business rules and logic on how we want to manage that scaling. So we can do it automatically. I can set it from 1 VM to 5 VMs, or I can set rules for example, if my CPU load is at 80% across that cluster, maybe I want to have 3 more machines to lower the load so we're not reaching 100% and having issues. What we also see is around time of day is a common one. So we've got a line of business app running. It has a lot of demand from 8 a.m. to 5 p.m. As soon as everybody goes home for the evening, the demand drops off. We don't need as much capacity. That's where we could scale in from a horizontal standpoint to less instances of those VMs, saving us quite a bit of money, as you mentioned.
And in the architecture of this application, probably a reference architecture, is that we have the 2 tiers, the business tier and the web tier, that can scale independently, right?
Yes, absolutely. So we're by again having those split out into multiple tiers, multiple VM scale sets, we can scale horizontally, both from the web tier and the API tier. We may have an application that serves a lot of front-end traffic, but because of caching, there's really not a lot of API load, for example. So we may not need to provision as many API virtual machines at that tier.
Or if we had some significant business logic in the API tier, that might need more horsepower.
Absolutely.
Well, so that's all we're talking right now about, an environment that's all within one Azure region, right? Let's talk about what if I have a user base that's around the world that needs to be able to access efficiently the local data center for Microsoft.
Right. So very early on here, we were talking about resource groups. And so a resource group was that logical container that wraps all of the resources that we need. If we wanted to, we started here in West US. If we wanted to make sure our East Coast customers were satisfied as well, we could just redeploy that resource group, the same one we did in the West US, over to East US, which would give an identical set of resources, but be located much closer to our end users, much less latency and much better performance there for them.
But we'll use the traffic manager to make sure that traffic from user traffic goes to the correct data center, right?
Exactly. Traffic Manager is our DNS-based load balancer of how we can split traffic between West US and East US. Traffic Manager sits in the middle and plays air traffic controller and says who goes to which data center. That can be based on several criteria. It could be where's my closest data center. And so it'll connect to the one that's closest and fastest. We can use this more as a primary with a secondary, more of a failover scenario. We can do just percentages, but 80% of traffic here, 20% there. We've got some options there with Traffic Manager to unlock different scenarios when we're load balancing.
So in a geographically distributed environment like that, I want to make sure that the data that people see is consistent, right? Yeah. That they have a consistent database view too, right? Absolutely. How do we do that?
Sure, so it depends on the type of database you're using, for sure. So we chose DocumentDB in part because one of the features of DocumentDB is the ability to have multiple secondaries in other regions. So you have a primary region and a bunch of secondaries. DocumentDB handles asynchronously replicating that data for you behind the scenes. It's transparent. I don't have to manage that process. It's done on my behalf, which is really nice. And also with this, it's all connected over the same connection string. So again, that's transparent to me, but I'm getting multiple secondaries in many locations there.
And then when I do writes to the database, that'll get handled automatically and distributed.
One of the benefits of a managed service, rather than having to maintain multiple highly available VM clusters all around the world. So.
Fantastic. So do we want to quickly show the architecture slides?
Sure. So we've been talking verbally about a lot of this. We did put together some diagrams to help explain how this all fits together. So let me flip over to starting with our single virtual machine architecture. So this was, when we first created that one virtual machine, we had web tier, API tier, data tier all in one VM.
Automatically created the network security group and the virtual network as well.
Yep, that was the NSG that we enabled port 80 to be able to access earlier, which is great. So that's where we started from. And from here we were talking about moving the state out of the machine using PaaS services. So this architecture grew and expanded out where we had that DocumentDB layer for our database. We moved our images over to blob storage, and we set up that caching layer that externalized the state and now allows that virtual machine to be much more stateless than it was before.
And then moving on to a multi-virtual machine approach.
Right, because right here we still have the web tier and the API tier all in one in the database. Next, we split those out into multiple tiers. So expanding this out, so you can see we've got a web subnet. We have a business subnet for our API tier, and then we have a management subnet, following a kind of a bastion host approach for security. What I want to call out here is because of these network security groups, we can lock down the flow of traffic inside of our application.
So the only traffic that'll reach our API tier is from the web tier on the proper port that you've already set up.
Exactly. So I can't just open a browser and open my API tier directly. We want to partition that off and secure that away from the public internet. The only other way would be with our jump box. If we needed to manage that API tier, we could go to the jump box first and then into that API tier.
Okay. So, and then how about the multi-region approach?
Okay, so as we moved out into multiple regions, so we have multiple tiers now across multiple regions. So these resource groups in West US and East US should look similar. They're all the same resources. We have moved over to virtual machine scale sets. So we have a very horizontally scalable option here where we define that master and a number of replicas. It manages that for us. But the biggest difference here is around Traffic Manager here on the top. So internet traffic comes in, Traffic Manager, based on the policy we define, tells the end user which region, which data center they wind up accessing our information there. And so the other piece we didn't chat a whole lot about was the content delivery network, the Azure CDN. This for those images, we could expose those images from a storage account via content delivery network, pushing those to multiple points of presence worldwide. Lots of options
Very
there.
close to the end user to give them a really good experience.
Yep. And finally, the App Insights piece. So we want to make sure we have logging
for
monitoring, being able to create custom events, get some very detailed metrics over how our app is performing, especially in a multiple geo scenario. App Insights does a great job of telling us how our application is performing with users around the country now.
Fantastic. Well, thank you, Stephen. And as a reminder, all the code and configurations that we used today are available on our Azure GitHub repository. Thank you for watching, and be sure to check out the other great content for Build this year.
Thank you very much.